Part A, factorise completely 9x minus 4x cubed. So first of all, I can see that I've got an x in both of these terms. So let's factorise that x outside. So that's going to give a 9 at the front, and then we've got a 4x squared at the back. Just double check. X times 9 is 9x, and the x times the 4x squared gives the 4x cubed. Now I just need to check, is that factorised completely? And no, it's not, because actually this can be factorised some more. This is the difference of two squares. 9 is a square number, 4x squared is a square number, and these are being subtracted. So therefore, I can rewrite this as being 3 plus 2x, 3 minus 2x. And just to double check that, the 3 times the 3 gives the 9. The 2x times the minus 2x gives the minus 4x squared. And then the 3 times the minus 2x gives minus 6x. The 2x times the 3 gives plus 6x. So the 6x and the minus 6x cancels out, and this is now correct and completely factorised. So this is your answer for part A. Part B, sketch the curve. So let me draw a set of axes. Here's my x-axis. Here's my y-axis. I need to show on the sketch the coordinates where the curve meets the x-axis. So I can see that it is going to intersect on the x-axis at 0, or minus 3 over 2, or minus 1.5, or plus 3 over 2, or plus 1.5. So it's intersecting at 0, at minus 1.5, and at plus 1.5. The other consideration I need to give here is whether it's going to be a positive x graph like that, or is it going to be a negative graph like that? Well, let's double check here. This is a negative 4x cubed. Therefore, it's that second option. It's going to be looking like this. So that's my answer for part B. We're then told the points A and B lie on the curve and have got x coordinates minus 2 and 1. Right, so minus 2 is roughly about here. X is minus 2 is roughly about here. Remember, this is minus 1.5, so minus 2 is a little bit below that. So therefore, this point here lies on the curve. This is my point A that's got an x coordinate of minus 2. Not quite sure what its y coordinate is yet. The coordinate B has got an x coordinate of 1. So 1 is going to be roughly about here. Again, remember this is 1.5, so 1 is going to be a little bit below that. So therefore, point B is here with x coordinate 1. And I want to show that the length of the line AB, so the length of this line is k root 10, where k is a constant to be found. Right, so let's work out the y coordinates of A and B, and then I can work out the length between them. To do that, let's focus on B first of all. I know the x coordinate is 1, so if I substitute 1 into my function here to work out the y coordinate, I'll get 9 times 1, which is 1, minus 4 times 1 cubed, which is 4, and I find that the y coordinate is 5. Now for the y coordinate at A. Remember, x is minus 2 at A, so if I substitute minus 2 into the function, 9 times minus 2 minus 4 times minus 2 cubed. So that gives me 14. So the y coordinate there is 14. Right, now to work out the distance between them. Some of you might remember the distance formula. Some others of you, I'm sure, will think of this in terms of Pythagoras. That's the way I think of it to save me from remembering extra formulae. Here's my point A here, here's my point B here. Focusing just on the x coordinates, the x coordinate here is minus 2, the x coordinate here is 1, so therefore this is 3. The horizontal distance between those 2 points is 3. Now focusing on the y coordinates, the y coordinate here is 14, the y coordinate here is 5. So 14 minus 5, difference between them is 9. So what we're saying here is to go from A to B, we're going along 3 in the x direction and then down 9. So to work out the distance between them, quick bit of Pythagoras. So 3 squared plus 9 squared square rooted is 9 plus 81, which is the square root of 90, which I can think of as being the square root of 9 times 10. The square root of 9 is 3. So 3 root 10 is the distance between A and B, which makes sense with what they've asked me to show here. So K is 3.